Welcome back to Math 107 College Algebra. In this video, we're going to take a look at how to find asymptotes of a rational function, whether they be vertical or non-vertical. So the first thing we want to talk about is what is a rational function. So a rational function, I'm going to call it r of x, but I can call it any letter I want, is equal to p of x over q of x, where p and q are polynomials. Now, immediately from previous study, we see that q of x in the denominator, and we start thinking about the idea q of x cannot be 0. So that's going to deal with our domain. So anywhere we get q of x equaling 0 is not going to be in the domain of a rational function. It actually turns out when we draw a graph like that, with one very uncommon exception that you probably will not see in this class. The behavior of the graph is I'll draw a dotted line to indicate an x value that's not part of the domain. That graph is going to get really close to that line but not touch it. The one exception we have is if there's a common factor of x minus c between the numerator and the denominator. In that case, you'll just have a hole in the graph. But where things get interesting, and this is one that I'll do an example on, is when we look at non-vertical asymptotes. So I might give you a function like x squared plus 7x plus 4 over x minus 1. So clearly, by what I said before, we have a vertical asymptote. At x equals 1. But then we look at other asymptotes we have. So what I'm going to do is I'm going to go ahead and do the division here. I'll use synthetic. So I can bring down the 1, then multiply by 1 and add. And multiply by 1 and add. And this is the spot where that remainder fraction is very important. Because I can say that graph is y equals x plus 8 plus 4 over x minus 1. Well, now I'm going to let x be really big. As I do that, I'm dividing by bigger and bigger numbers in that term. So, as x goes to infinity, that is going to go to 0. So the function is going to get really close to that line, x plus 8. So we're going to say, now the book separates horizontal asymptotes and oblique asymptotes, and then there's even things you could call asymptotes that aren't horizontal or oblique, which we'll talk about in class on Thursday. So in this case, I'm just going to say a non-vertical asymptote at y equals x plus 8. In this case, by the book's terminology, that's going to be an oblique asymptote. But for my purposes, just saying non-vertical will be sufficient. So in class Thursday, we'll talk more about asymptotes and the different types of asymptotes we might get of a function. And we'll see you on Thursday.